So let's now talk about congruent angles. So with congruent angles, just like we did with congruent segments, as I did in the previous video on angle addition, there has to be some sort of marking or notation in the picture that indicates that the angles are congruent. So they're either going to, in the direction, tell you that the angles are congruent, and the symbol for congruent is that equal sign with a squiggle on top of it. I mentioned that back when we were doing segments. And so I also have an important note here. When we talk about angles, you're going to see the difference. You're going to see, and up here, I should have pointed it out, that little M says, I'm looking for the measure of the angle. That's what I want to know. So that little M indicates I'm talking about the measure of the angle. If you're using that M, then that tells you that you're talking about equals, because measures are equals. If I instead just say angle QRS or angle RTS without the little M in front of it, that's when the congruent signal, because that congruent symbol is used, because that's indicating that we're talking about the actual object of the angle or that actual physical location. So how can we mark that angles are congruent? When we did segments, we used those little hash marks. Now, instead, we're going to use these little arcs. So they're just small little curves within the angles. And as we did with hash marks, 1 matched with 1, 2 matched with 2, 3 matched with 3. With angles, the same idea. 1 matches with 1, 2 matches with 2, 3 matches with 3. So we would say, based off of this picture, that angle S is congruent to angle B. We would say that angle R is congruent to angle A. And finally, we would say that angle T is congruent to angle C. So that's what those little marks are telling us, and we can create these statements. What I don't know is S congruent to R? I doubt it because of the way we've marked the picture. So this indicates that we have 3 different measures because we have 1 mark, 2 mark, 3 marks. So you wouldn't want to assume, even though it might look or appear to you like maybe R and T are about the same size, we don't know that because this one has 2 marks and this has 3 marks. All we know is the angles in triangle TSR are matched to the triangle CBA. In a picture, another way sometimes we will mark the picture is you might see that we'll put the little mark with a hash mark. Some books choose to use that. That indicates they're the same. The hardest part that can often happen, and if you ever have questions reading a picture, please let me know, because each book does it slightly differently. Sometimes the marks look like they're interacting with each other. This is really intended to be a single arc on this side and then 2 arcs on this side. I prefer books that don't line them up because that can be confusing. So if you ever have questions off a picture, don't hesitate to reach out. So let's continue on to the examples on the next page. So what else could be in the directions that tell you that the angle has been cut in half? One of those is by calling something an angle bisector. We used the word bisector back when we did segments. We said a bisector is any object, point, ray, line that divided our segment into 2 congruent parts. Now that we are talking about an angle bisector, it's going to specifically be a ray because an angle is made up of rays, as we talked about in the angle video. And so it's just a third angle or a third ray that is cutting through the angle, dividing it in half. So the idea is this picture started out with the entire angle AXC, and now XB has been drawn in as a ray, and that should have a ray symbol on it. That's a little typo in my notes there. That XB should be the angle bisector of this entire angle. So what that's telling the reader is that the left part or the upper part of the angle and the bottom part of the angle should match each other. So when they tell me that AXB equals 23 degrees, if I know the top is 23 degrees, then I know the bottom has to be 23 degrees because of that word angle bisector. So that bisector divided that entire angle in half. So now what we can ask you is, well, what are the parts and what's the whole thing now that we have labeled? So when I ask for what is BXC, we just went through, because this is bisected, BXC must be 23 degrees. But then if I then go back and say, well, then what does that mean for the size of the entire angle? AXC, well, now I have my two parts. I can add those two parts together. 23 plus 23 should give me 46 degrees. You can also take the angle and multiply it by 2. Both get you to that same result of 46 degrees. Now in this picture, a little algebra, just like we did with segments. When I tell you that ray BD bisects ABC, that tells me that this ray is cutting the entire angle in half. So the left part of the angle and the right part of the angle have to be equal to one another. So just like we did with segments, left equals right. So I'm going to set it up as 3x plus 17 equals 7x minus 39. Want to make sure that you follow through with your algebra. So I like to keep my x's positive, so I'm going to subtract 3x from both sides. That's going to leave me 17 on the left, 4x minus 39 on the right. I'll now add my 39. It's going to leave me 4x on the right, and that's going to leave me 56 on the left. And then I'm going to divide by my 4, and that's going to give me 14 for an x value. But you do want to be careful. If I go up to the original question, it said I want to find the measure of ABC. The directions did not say what is the value of x for this angle. So because it did not ask for the value of x and it asked for the measure of angle ABC, I do have to plug that x value back in to turn it back into a degree measurement. Variables are not degrees or lengths. They're just a value for the variable within the expression. So I still have to plug that 14 back in. Now you might notice I don't have a value or an expression to represent the entire angle to plug it into for ABC. So I can plug it in both the left and the right and then add them together. Now we do know that these are supposed to be equal, so you could go with the idea that I'm going to plug it in one and then double it. I like to plug it in both because it's also a check to make sure that I did my algebra correctly. Because if I plug it in the left and I plug it in the right and I get two different numbers, then I know something's wrong with my algebra. So I do usually plug it into both just to give myself that extra check. So if I come over here and I write, spending too much time on a computer, if I write 3 times 14 added to 17, and then I take my handy dandy calculator, I feel like Blue's Clues, your handy dandy notebook, 3 times 14 plus 17 gives me 59 degrees. I'm going to do the right-hand side, so I'm going to take the 7, multiply it by the 14, minus 39. Again, put that in the calculator, 7 times 14, minus 39. I also get 59. So that gives me that reassurance that my algebra was done correctly because I did get the same number on the left and the right. And then 59 plus 59 gives me a value of 118. So the measure of angle ABC would have to equal a total of 118, which are the two parts together. So that now goes through angle bisectors and congruent angles. So put with the angle addition, you can now complete the practice that allows you to put the two together.